Have you ever wondered how computers talk to each other? Well, stick around for this episode where we learn how TCP/IP plays matchmaker.
You're watching IT Pro TV.
Hello and welcome to another empowering episode here at IT Pro TV. This is your Linux Essential series, and in this episode we're going to be taking a look at basic networking elements, and here with us is Don Pizzette. How's it going, Don?
It is going great. Ready to take a look at networking under Linux. You know, it's pretty much a given these days that when you use a computer, it's going to have internet access. That means you're talking to computers that may be on your own network, that may be across the world. How the heck does that work? Well, we're going to take a look at some of the basic elements that are involved in networking so that we have an understanding of one, what's required of us to talk, and then two, a basic understanding of how we're able to talk between those two machines. These are all really important skills to have if you're going to continue to learn things like troubleshooting network and actually configuring networking. You probably need to have a basic understanding of how it functions. So we're going to take a look at some of the things like how IP addresses work. We'll also take a look at TCP/IP and how that protocol suite works and communicates. And then I'll show you a demonstration of how we can see a lot of the stuff that goes on behind the scenes that the computers hide from us. It's actually fairly complex, but is done thousands and thousands of times per day as you browse the internet.
So, big question, how do computers find each other on the internet?
All right, well, you know, if I wanted to give you directions to somewhere, right? So I said, hey, meet me at this restaurant.
Right.
And you've never heard of that restaurant. I'm probably going to give you at a minimum an address.
Right.
And with that address, you might be able to find your way there, right? If you had a
Yeah.
GPS or something or an atlas. If you didn't,
Did you say an atlas?
an atlas?
Yeah, okay. Yeah.
They still make those, right?
They do. But
You've never used an atlas, have you?
I have, but
Okay.
it's just like, does anybody still use it?
All right, so, but imagine you didn't, right? Imagine I gave you an address, but you didn't have an atlas or
Okay.
a GPS or anything like that. The address might be useless to you.
Yeah.
I mean, you might be able to ask other people, hey, do you know where Smith Street is? And maybe somebody does. Well, that's how computers are. In order for two computers to talk to each other, at a minimum, they're going to need an address. Now, if I give you an address on Smith Street and you live on Smith Street, you can work things out just based on the number, right? Our building here is 7525 Northwest 4th Boulevard. So if I need to find 7535 Northwest 4th Boulevard, it's probably just
Just down the road?
just walk down the road, I'll hit it, no problem, right?
Yeah.
You can figure it out. That's how computers are. If it sees another computer with an address on the same network, hey, I can just stumble around right here on the local network. I'll find the machine. But if it sees a completely different street name, well, now it's got to figure out where that street is. And in order to do that, it has to talk to a router. So your computer doesn't actually know how to get from point A to point B to talk to those other computers. It relies on a router to do that. The router is really important. And that's why most home networks, practically all businesses, anybody connected to the internet is going to be using a router of some sort. If you don't have a router, then your ISP is providing it for you, and it may even not be in your building. It might be on their end of the cable, but they will provide that routing functionality so you can find your way across the network. So on your computer, you have to have a way to tell who's on your network and who isn't. And we do that with IP addresses. Now let me show you here on this Ubuntu system. There's a few ways we can set this up, like through the GUI or through the command line. I'm going to use the command line here. And the command I'm going to use is IP space ADDR. All right. And this is going to show my IP addressing settings. And when I look at that, it's going to show that I have a loopback adapter. That's for when my system needs to talk to itself, right? It's like it's conscience, when Jiminy Cricket.
Yeah.
And then I've got this other one, ENS33. That is my actual Ethernet adapter, the cable that I've got plugged into the side of my laptop here. And I can see that it has an INET address. That's my internet address. And mine is 192.168.50.129/24. All right. Now, that address, it looks like a number, right? It is a number. But to the computer, it's actually a binary number. And it's a 32-bit binary number. So it's made up of 32 bits. And that /24 there at the end is telling me that the first 24 bits correspond to the network ID. In other words, that's these first three numbers here. 192.168.50 is the network ID. That would be like the street name in a regular address. And then the last part here, these would be the remaining 8 bits. Those are the host ID. And that would be like your building number in an address. I said we were 7525 Northwest 4th Boulevard. Well, the 7525, that would be like this part right here. Okay. And so if my computer wants to talk to somebody else and their address starts with 192.168.50, I'm going to know, hey, they're on the same network as me. I can just shout out on the network and find them. They'll hear me and they'll respond. But if their address doesn't start with 192.168.50, if it starts with something else, they're on a different street. I can shout my lungs out. They're not going to hear me. I'm going to have to go and talk to a router to be able to get there, right? And if you run the IP route command, this is a little bit different. You'll actually see your routing table and get an idea of what those networks are. And I can see right here is the 192.168.50 network that I'm plugged into. But then I've got this default route. And the default route is me saying, if I don't know how to get somewhere, here's the router that I'm going to talk to. 192.168.50.2 is apparently a router, and I can talk to them, and they'll get me to where I'm going. So that's kind of how this works. Now, networks are normally divided up into streets like this. In my example, it was these first 3 octets, these first 3 numbers here that made up that network ID, but it's not always that way. In fact, in the olden days, we had classes. So there were Class A networks, Class B networks, and Class C networks. And basically the way they worked was they would assign a different number of bits for the network ID. So for example, a Class A would just use 8 bits, a Class B would use 16 bits, and a Class C would use 24 bits. That's that /24 we saw earlier. And those would create networks of different sizes. A Class A network would actually be about 16 million hosts, right around there, right? A Class B would create around 65,000 hosts, right? And then a Class C would create around 250 hosts. Those are the sizes of the networks. You're getting increasingly smaller as you go to the lower classes. And that's how you'll normally see your networks divided. That /24 tells me I'm on a network that's got, it's actually got 254 hosts is the exact number if we want to be really precise on this stuff, or 65,534, or 16 million would actually be 16, let's see, I've got it written down so I can cheat a little bit, 214 million hosts. All right, so those are kind of how those networks get divided.
Don, how do we choose which addresses we use?
Yeah, so in my example here, my computer already has an address of 192.160.50.129. How did I know to use it?
Right.
Well, I didn't. so I plugged my computer in. Actually, before we hit record on this episode, I didn't know what my IP was because I didn't have to. Most networks use DHCP, Dynamic Host Configuration Protocol. And that means when your computer turns on, it doesn't have an address. And it just asks the network, says, hey, can somebody give me an address? And there's usually a DHCP server on the network that will respond and say, here's an address you can use, right? And the DHCP server is oftentimes your router. At home, it's almost certainly going to be your router. In a business or enterprise network, it might actually be a dedicated DHCP server, but it's going to assign you an address. Now, when it assigns you an address, it's usually going to be a private address. There's different types of addressing out there. Private addresses are ones that we can freely use, and you can pick and choose amongst them. There's an RFC, a request for comment, basically like an IEEE standard that defines what private addresses you're allowed to use. It's called RFC 1918. And it defines 3 primary ranges to use. And so you'll see these a lot. One range is the Class C range that's defined. It's 192.168.something.something, right? And when I say something.something, it doesn't mean I forgot. It just means you can pick whatever you want in there, right? Gotcha. So 192.168.x.x/24. So that's available to use for a Class C range if you want, and it's covered in that private range. You're free to choose inside of it. On the Class B side, it's a little bit weirder because it's 172.16.x.x, but then it goes all the way through to 172.31.x.x like that. So you could have 172.18, 172.22, 172.30, right, followed by 2 values that you choose. And then on the Class A side, it is 10.x.x.x, right? So it would just start with 10 to create that class there. So little variations. If you're responsible for designing a network from scratch and you have to pick a range, you're normally going to pick one of these ranges. These are the private IP addresses, and that's why you'll see those when you're in Starbucks and you get on their wireless, when you're at an airport or a hotel, when you're at home and you buy that brand new wireless router and plug it in. It's normally going to automatically issue out an address like this. But on the internet, we have to use public addresses. Addresses that are registered and reserved, that are unique just to us, that no one else on the planet can use. And those addresses are limited, so most of us don't have a ton of them. In fact, we'll usually just have one assigned to our router and all of our machines will share it, right? And those addresses can vary pretty greatly. They'll normally bounce around and really it kind of skips a few values. So it starts at 1.0.0.0.
These are public, not private, right?
These are public.
Okay.
Yep. So these are ones that would have to be registered. So they start at 1.0.0.0, and that goes all the way to 126.255.255.255. It stops at 127. And that's because 127 is reserved. It's a special thing for loopback when you need to talk to yourself. In fact, I probably should have seen that back here on my loopback adapter. Yeah, see how it says 127.0.0.1?
Yep.
That's in that range. And it's a /8 telling me it's a class A. That 127, the whole block is shut off. And then it picks back up again right afterwards with 128.0.0.0. And that runs all the way to 191.255.255.255. It stops to make room for, 191, there we go, .255. It stops to make room for that Class C private range at 192.168. That's why we kind of had to stop. Hang on, I have more than one mistake in here. 191, oh no, that is right.
That's
okay.
Right.
Yep, sorry, thought I was wrong. And then we're going to pick back up at 190, well, technically it picks back up at 192 and extends out from there all the way to 223.255.255.255, which is where the primary address space stops. So those right there are the public ranges that you're going to see out there on the internet. Now, we don't just make these up and assign them. These are ones that have to be registered. We have to be given them so that we're unique across the entire planet. So normally our internet service providers are the ones who are going to manage those, and you won't typically see them on your own machine.
We've been talking about IP, but what about TCP/IP? Because we mentioned that earlier. When does that come into play?
Yeah, and a lot of people refer to them together, TCP/IP.
Okay.
Right? But it is two different protocols. Mm-hmm. And remember, IP, it stands for Internet Protocol. I don't remember if I said that earlier or not, but Internet Protocol, it just means this is the addressing that helps us find somebody. But once we find them, we've got to be able to talk to them. How do we do that?
Right.
Well, that's where TCP comes in. That's Transmission Control Protocol. Like if I want to have a conversation with Aubrey, first off, I've got to find you, right? And that's what IP would do. It would help me find you.
Right.
But then once I find you, I've got to have a way to talk to you. And here, I use words, you hear them in your ear, and we communicate.
Yeah.
With computers, they use TCP. TCP takes whatever our data is, breaks it up into little fragments, or actually called segments, breaks them up into these little segments, and sends them along to the other side. And at the other side, it reassembles them together and then interprets them, right? And then can respond back and do all of that. Now, the most common communication protocol used across the internet is TCP/IP. That whole protocol stack is how they refer to it. There are other protocols out there, things like UDP. TCP is a reliable transport mechanism. And by reliable, what I mean is if I send some information over to a server and it doesn't make it, the other server will know that it didn't get the data, and it can re-request it, and I can retransmit it. But there are protocols like UDP, User Datagram Protocol, that do it's called a best effort. They'll try to get the data to the other side, but if it doesn't get there, they just give up, and they move on and transmit other things. That's used with like streaming video. If you're watching something live and you drop a frame, well, you don't want to freeze the video while you go and retransmit that frame. You just skip the frame and move on. If you're watching a football game and the ball is going across the screen, you don't want it to just stop. You just want it to jump ahead a little bit and keep going.
Yeah.
And so those are examples of where other protocols would be used. But TCP does reliable transmission, and that is usually what we want. If I send an email, I want the whole email to get there, not just
a piece of it.
yeah, 9 out of 10 sentences. Who knows how that'll end up? So that's why that protocol gets used. And people do refer to them together. TCP really is built on top of IP. IP can operate without TCP, though. Just remember that. But most things are going to use TCP.
Is this something that we could take a look at in the background?
Sort of, yeah. It's not totally obvious.
Okay.
On your computer, even the mundane things you do on the internet are using TCP/IP constantly, right? Let me show you an example here. I'm going to fire up a web browser. And if I go to a website, right? So like if I go to the IT Pro TV website, I'll type in itpro.tv. What just happened is it took the name that I typed and it used DNS to turn it into a number to figure out the IP address. And then it had to find a way to get to that IP address. And once it got to the IP address, then it had to talk to the server and ask for a copy of the web page. And so it used IP to find the server and TCP to get a copy of the web page. But I didn't see any of that, right? It's all masked and behind scenes.
Right.
And most of it happens so quick that even in the background, I'm not going to be able to see that that happened. So let me do something. We'll have a little fun here. I'm assuming you've seen the movie Star Wars.
Yes.
So a few years back, actually probably 20 years back now, a group of college students actually made the movie Star Wars in an ASCII animation, total text, the entire movie. It's pretty ridiculous. And it's basically available via Telnet. And so you can Telnet to their server. Now their server, here, let me pull up the address first. I'm going to use the dig command to convert a name to a number. Their server is towel.blinkenlights.nl. All right, so looking at that, I can see the address of their server is 94.142.241.111. All right, I'm going to remember that address.
All right.
At least I say I'll remember it. Let me copy that because I'll forget it. Now I'm going to connect to that server. And so I'll just do a telnet. Actually, before I do the telnet, I'm going to jump over to another tab, and I'm going to use a command called SS. All right. This command shows me statistics about all the various network communications that are going on my system. And so I can do SS-AN, which is going to show me all communications, and it's going to try and skip name resolution and just show me numbers when possible. And I'm going to filter that with the grep command and look for that IP address that I just resolved a moment ago, right? The Blinken Lights server. And when I run that, I get nothing back. So right now I have no connections open to that server, which is what I expect. I'll jump back over to my other tab, and I'm going to open up that Telnet session. And when I do, it's going to connect to their server, and it's going to run some of their little credits and things like that, and then the movie's going to start. So this connection is going to stay open. When you talk to a web server, you normally connect to the server, it sends you the page, and then the session goes idle. And unless you click on something, you actually disconnect from that server. Or, it may, yeah, I know, it's pretty neat. Or, you may keep that connection open for a little while, but eventually it's going to close. And so it's hard to keep track of. The things happen very fast. So I picked this one because it's going to hold that session open and keep going. All right, so if you're ever bored, it's pretty
Watch the whole thing.
So I'm going to go back over here, and I'm just going to rerun that same command. And now I get a response back. All right, I have an established TCP session, right? Transmission Control Protocol is connected to that server. So there's the server, 94.142.241.111, and I'm connected on port 23, which is the port that Telnet uses. And I'm exchanging information between my address and them, right? That communication is moving back and forth. And I could use a utility like TCP dump to actually dump and see the data moving across in its raw form. But right here, I can see that TCP session. I can see the port numbers that it's using. And if I were to close that session and break this connection, so let me go ahead and close it. All right, that connection might not go away. Oh, it went away right away. Huh. Sometimes they'll hang around for a little bit waiting to reconnect. But I guess since I used the close command, it knew I actually wanted to close it out. So that connection is now gone, and I've no longer got it open. But that's TCP/IP at work, right? It was making sure that I was getting every single piece of information for that session.
So this has been basic networking elements, and the big takeaway is that we can watch Star Wars at work, and it looks like we're actually doing something.
It's what the internet was invented for.
That's true.
I do want to mention, we basically spent this episode looking at how things work. Stay tuned, because in our next episode, we're going to see how to actually configure things, get in there and change them and manipulate them. But we need to have an understanding of how things work before we start changing them. Otherwise, we're going to break something.
All right. Well, thank you so much, Don, for guiding us through that. And thank you all there for watching. Signing off for IT Pro TV, I've been your host, Aubrey Spurgeon.
And I'm Don Pizzette.
And we'll see you next time.
Thank you for watching IT Pro TV.
Configuring a network adapter in Linux can be pretty confusing. Stay tuned to find out the 3 common ways to do it.
You're watching IT Pro TV.
Hello and welcome to another exciting episode here at IT Pro TV. This is your Linux Essentials series, and in this episode we're going to be configuring a network adapter. And with us is Don Pizzette. How's it going, Don?
It is going well. You hit the nail on the head saying that network configurations can be a little confusing.
Yeah.
And that's because there's so many different options in Linux. And so what we're going to do in this episode is take a look at how to identify what name our network adapter has. That's a challenge right from the very beginning, even though it shouldn't be. And then we'll take a look at 3 different ways we can configure it via command scripts, via the Network Manager graphical user interface, and via the Network Manager command line interface. A couple of different ways out there to be able to configure these.
How do we view our current network configuration?
All right, there's a few different ways, and this is where it gets really challenging because it can vary so much from distro to distro, right? So what I like to do is I like to rely on things that I know will work. I know in the GUI, on most distros, they're running GNOME. And so in the top right corner of your screen, you should see a network icon, and it's probably pretty tiny like mine is up here, this little network icon. But if you click on it, you'll see, like for me, I've got wired connection. And if I click on that, I can go in and pull up my wired settings and view information about the adapter. If it was wireless, I would see information about the wireless. So, that's available. Assuming your GUI has that icon, or assuming you have a GUI at all, right? On a server, you might not even have that. So personally, I don't normally rely on those. It's far easier to just drop to your command prompt and use some really handy commands. The most handy command, in my opinion, is IP ADDR. IP space ADDR. This is the IP command, so this is your IP configuration. I'm just telling it to show me my addressing. When you run that, it will tell you the name of each of your network adapters and show you the configuration. I've got one here that's a loopback, so it just says LO. But beneath that is ENS33, and I can see my IP address right there. I can see basic information. This is telling me how my network is configured. And I can go a little further and do like IP route to see who my default gateway is. Mine is 192.168.50.2, and that information is there. Now, as you browse around the internet, you might also find documentation that refers to other commands like ifconfig. That's an older command, interface configuration. It still works on most distros, but it has been deprecated, so it's going to go away soon. Now, soon in the Linux world could mean years, but notice here, on this Ubuntu system, it doesn't have the ifconfig command, but it's telling me I could install it if I want it. It's just not there. So if you're still using ifconfig, consider transitioning over to IP ADDR. That's the newer version.
So where are the network interface configurations stored?
That's going to vary pretty heavily as well, right? So to find out where they're stored, we really need to understand what distro we're using, right? So for example, Red Hat-based distribution, so like CentOS. Let me jump over to a CentOS machine here. So this machine is running CentOS 8. And if I take a look at it, I can find the network configurations inside of the etc folder. If you go into /etc/sysconfig/network-scripts, what you'll find in there are a collection of files that configure your network adapters. So on my system, I had a network adapter, ENS33, and I can see it right here. It has a text file. All that is a text file. And if I look at that file, it has the basic settings on here. I can see like this one has a boot protocol of DHCP, so it's set to get an automatic address, and I can see that name assigned, whether it's turned on when we boot up or not. If I had a static IP, it would say IPv4_ADDR1 equals blah, 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 and you could specify that address. So all of those settings would be right here in this text file. And when your system boots up or the network card goes active, it would read this file, and that would pull the configuration. The hardest part about this is just figuring out which file pertains to your adapter. I guess my system's a little easy because I just have one, and so I know that's the right one. But if I had 5 network adapters, what does ENS33 mean to me? Not a whole heck of a lot.
Not a lot, yeah.
But there is a little bit coded in the name, right? So IFCFG, that just means interface config. And then EN. EN is short for Ethernet. This is a copper Ethernet jack. You might also see WL. That would be a wireless LAN. So if you had a wireless card, it would show as WL. If you see WW, that's a cell card, right? Or a wireless WAN is what that one stands for. So WW. The next letter, in my case, is an S, is talking about where this one is connected to. So an S means that this is a hot plug slot. So it's showing as like a USB type connection. You might also see an O. O is really common because that means on board. It's integrated onto your motherboard. So ENO33 if it was on mine. And then you might also see P, so ENP. That would be a PCI card, so an add-in board. So that helps you kind of figure out which adapter it's referring to. The numbers at the end, though, well, those are just generated by the distro. A lot of distros start at 0, and so you'll see ENS 0 or ENO 0, ENO 1, ENO 2. So they're numbering them based on their position on the bus. Mine jumped to 33. I don't actually know why, but if it's a USB device, there may be 32 other USB identifiers that have already been taken, and so then this is the next one if I've plugged and unplugged a lot of different things on the system. That's what I ended up with. But if I want to configure this or see the configuration for this adapter, I can find it right there in that text file. I can edit it, modify it, and now the adapter is set up the way that I want it.
So we talked about 3 ways to do this. So what is I guess an easier way to do some configuring network settings?
Yeah, the text files like this are kind of the hardest way to do it.
Okay.
But because one, we have to figure out where the text file is.
Yeah.
Right. Figure out the right name, and then get the syntax right inside of the file. There's a lot of challenges there, and a lot of places you can go wrong. All right. But the other challenge is that not every system has these text files. Let me go back to my Ubuntu system, so we'll have some fun here. And I'm going to go into /etc. I'm going to go into sysconfig. Wait a minute. It doesn't even have a sysconfig folder, right? So it doesn't store text files with that configuration the same way that we're doing over in the Red Hat-based system. So now I've got to go and figure out, where is this buried away? Well, this became a problem about 10 years ago. And Red Hat actually, even though Red Hat has the text files, they kind of pushed one of the big solutions for this, which is a utility called the Network Manager. The Network Manager is designed to manage the network, but to allow you to go one place to configure your network adapters and not have to worry about where the distro is storing the config files. That's way easier. And it comes in 2 different forms. There's the GUI version of the Network Manager, which is actually what is creating this icon at the top right of my screen. That is the Network Manager right here in the GUI, and I can go in and I can pull up the wired settings for my adapter. It's going to come up, and I can go through and start to configure and change that, assigning addresses and all those various things that I might want to do, all right here in a GUI utility. So the GUI is really nice, all right? But if you're working with a server, you probably don't have the GUI, right? So now you've got a bigger challenge. Well, the Network Manager GUI is nice, but there's actually a Network Manager TUI.
What does that stand for?
So normally you have GUI, graphical user interface.
Right.
TUI is a text user interface.
Oh, okay.
And it's pretty neat. Like, remembering command line stuff is a pain, right?
Yeah.
But if you go to your command prompt and do NMTUI, Network Manager Text User Interface, NMTUI, when you run that, you get a text-based interface, but it's menu-driven, which is a heck of a lot easier than running a command line. So I can choose to edit a connection. I see wired connection 1. I can choose to edit that, and then I can come in and I can set my IPv4. Maybe I want to go to a manual address, and I can view what my current address is. I can punch in my gateway and so on, and it's all done through a simple text interface. This has all the advantages of using the GUI, but doesn't rely on the GUI to be able to get in and do it. This is a really cool way to do it if you're doing it by hand. Okay, so if I just need to get a network configuration put in place by hand, I'll usually fire up the NMTUI. It's not installed on every distro. In fact, let me go back over to Red Hat or CentOS. So over here, if I do NMTUI, oh, it is installed. Okay. If it's not installed, it's usually just a quick matter of installing it. The package is usually called NMTUI, and you've got it. So not a big deal to get that one up and running. But if you don't have it, you might have another option, which is the NMCLI, or the Network Manager Command Line Interface. The NMTUI is good for me interacting with it manually. I can go through and configure one adapter. But what if I want to write a script or automate assigning an address? What if I want to change the DNS servers used by 100 servers? I don't want to log in 100 times and go into NMTUI and go in and change that DNS value. Yep. That would take too long.
Yeah.
The NMCLI, though, is scriptable. I can script commands. The commands are harder to remember, but I can script them and push them out to a system. So let me get out of the NMTUI, and I will show you that. The NMCLI is the Network Manager Command Line Interface, and if you just run it, it'll show you a summary of your current configuration. So you can actually use the NMCLI as a replacement for the IPADDR command I showed you earlier. I see wired connection 1 is ENS33. I see its IP address. I see its routing information. I see my DNS configuration. It's all right here. pretty nice way to quickly view your configuration. But we can also edit the configuration. So like, let's say I wanted to change that DNS server. What I would do is I would run nmcli connection edit, and then the name of the network adapter. Now here's where it gets tricky. Your network adapter has two names.
Oh.
There's the name the operating system gave it, which in my case was ENS33, and then there's the name the network manager gave it. And the network manager gave mine a name of wired connection 1. So I actually have to type nmcli connection edit wired connection 1. And if you don't know the name, just run nmcli, and it'll show you the physical name mapped to the logical name. And when I run that, I'm now editing the settings for that connection. All right, and I can come in and modify these, and these are all scriptable commands, ones that I could easily pass through without actual interaction. So I might want to do print to actually see the current configuration. So if I find like what my DNS servers are set to, well, I'm using DHCP, so I don't actually have DNS servers set right now. So if I want to set one though, I could say set IPv4.DNS and then specify a server like that. And so that's going to set that address and put it in place. And when I'm sure that I've got it all correct, I can save the configuration and then I can quit out. And so now that should have taken effect. If I do nmcli and take a look, did it take effect? Oh, shoot. I set it on the adapter. It's being globally overridden.
Oh, okay.
This is another challenge we bump into where settings can be pulled from global versus an individual interface. So if I were to get back into the nmcli and do a print, I should see that it took place there. Yeah, right here. So here's where it took place on the individual interface. So it's set. And the best part here is that I could have put this into a script. Instead of doing nmcli connection edit, I could have done nmcli connection set IPv4.DNS server and so on, and just kind of pushed it via the command. A little more involved, but much more ideal if you're going to be scripting a solution.
All right, this has been Configuring a Network Adapter. There are 3 common ways to do so. Give us a little reminder of what those 3 ways are.
So if you're doing it by hand and you have a GUI, use the GUI. That's going to be the easiest way to do it. If you don't have a GUI, you can edit the configuration files found in /etc/sysconfig/network-scripts, or you can use the NMTUI, the text user interface, to be able to edit it that way by hand. If you're scripting, you'll want to use nmcli to be able to automate that and push it out across however many servers.
All right. Thank you so much, Don, for guiding us through that. And thank you all out there for watching. Signing off for IT Pro TV, I've been your host, Aubrey Spurgeon.
And I'm Don Pizzette.
And we'll see you next time.
Thank you for watching IT Pro TV.
Unfortunately, there's more than one way to configure DNS under Linux. Stay tuned to find out the 3 common ways, and we'll figure out how to determine which one is best to use.
You're watching IT Pro TV.
Hello and welcome to another empowering episode here at IT Pro TV. This is your Linux Essential series, and in this episode we're going to be configuring name resolution. And here with us today, as always, is Don Pizzette. How's it going, Don?
It is going great. Ready to take a look at the world of DNS resolution, which you would think would be simple, but you've got a lot of options under Linux. Today we're going to learn a little bit about setting those configuration options via the network manager, either in the GUI or the CLI. We're also going to take a look at the Resolve, our DNS resolver service, and how that can be used for name resolution, and a few other little gotchas that we kind of get caught on along the way. So that's all coming up in this episode.
So there's 3 different ways that we can configure. So what's the easiest way to configure?
Yep. So, and just to clarify, there's 3 primary ways.
Primary, okay,
in
common.
Linux, the sky's the limit.
Yeah.
All sorts of crazy stuff out there. But when it comes to setting what DNS server you're going to use, there's really one primary way if you're on a desktop, and that's using the GUI. That's the easiest way to get in and set your DNS resolution values. So for example, here on my Ubuntu box, it's super easy to just go up to my menu and click on the network icon up there, and then go into my wired connection, my wired settings, and then inside of the connections for that adapter, I can pull up the settings for the adapter and go into IPv4. It's buried way deep, but eventually I get to where my DNS settings are and I can change those values. I'm going to say it's super easy. I did have to click on like 5 different things, but we just get in there and change it, and that's it. Now, sometimes your changes don't take effect until you turn your adapter off and back on again. Mine's also set to an automatic address, not a manual, so I probably need to turn that off. to go manual to make sure that that's set so that DHCP won't override what I put in here. But that's a pretty easy way to get that set using the Network Manager GUI. And then if you don't have the GUI, you've also got the Network Manager CLI that you can use. So from the command line, I could have said nm CLI connection, and then whatever the name of my connection is. And we saw this in a previous episode where I took my wired connection one. Oh, I'm leaving off edit. So I want to do nm CLI connection edit, followed by the name of that adapter. And from here, we can just specify set IPv4.DNS, and then the name or number of that DNS server that I want to use. That puts it in place. We can save that configuration and quit out of that. And so that assigns it. Both of those are using the Network Manager. It's just one is using the GUI, one is using the command line. And those are two pretty safe ways to get in and change those values.
Is the Network Manager installed on servers as well?
Isn't it some? Like
Okay.
if you're running the Ubuntu server, yes, it's got it. But a lot of other servers, especially when you deal with like Arch Linux and Slackware and those guys, will not have the Network
Okay.
Manager available. Most of them still rely on the older DNS resolver. And so you'll find the DNS resolver is supported across all the distros. It might not be installed by default though. So it's a bit hit or miss what your system is going to actually use. And that's why I encourage you to use the GUI or the Network Manager if you can, because it kind of sorts everything else out on the back end. But if you're not sure, then you might have a system that's still using the old resolver system. If you take a look inside of the /etc folder, you'll find a file called resolve.conf. I'm going to do cat /etc/resolve.conf. And I'm expecting one of two things here. One, the file might not exist, right? Which means I'm not using it. Or two, the file might indicate where I should be going to configure this, not this location. And so when I look at it, sure enough, I get this file is managed by systemd-resolved, the resolve daemon. Do not edit. So it's telling me right now, like, this file is not in use, right? This is the older way. What you used to do is edit this file and come in and just set your name server. See the name server down here? Right now mine's set to well, apparently myself, but you could set it to 8.8.8.8 or whatever DNS server it is that you're using. You would just punch it right in there. And the next time your network service restarted, that would get loaded. All right, but that's not really used anymore. And so if you want to change that option, you need to go to a different place. And that different place is /etc/resolve.conf.d. That folder, which doesn't even exist on my system, is where you can put overrides in. And systemd will read those overrides and load that into the resolver configuration. So let me just go into /etc/resolve.conf. And in that folder, oh yeah, I do not have it. So if I want to do an override value, I would just need to create a resolve.conf.d folder. And then I could put text files of pretty much any name. And those would allow me to override the name server right in there. So we could do it using that. You do need to be an admin to edit files in this folder. So if you want to change them, you'll need to do like sudo and then whatever your text editor is. Or most systems have sudo edit, which is an alias for using the sudo command and whatever your default text editor is to run and then edit that file with administrative permissions. But you can get in and change that file, modify the settings, and restart it. Now, if my system actually used the resolve.conf file, which again, several distros still do, I would say sudo edit /etc/resolve.conf, and that would edit that file. And oh, I got a warning here about it being a symbolic link, and so it's not going to let me edit it that way. Let me just do a regular sudo, and we will just use vim, which vim is not there. Great. See, these are the challenges when we jump from OS to OS. There we go. So now I'm editing that file, and I would just go in and change it and save that. Now, if it's a systemd system, I would need to restart the resolver service. So you would just use systemctl restart resolved. So like this, systemctl restart resolved, like that. Whoops, which I need to be an administrator to do. And that's going to make it reload those configuration files and get it put in place. Mine says it's not using it because it's actually using the network manager to manage all this stuff. But on a system that had it, that would restart it. If I had a really old system that didn't have systemd, then I would need to use the service resolved restart command, and then that would restart it that way. So these are some of the big challenges when you move from system to system. You may need to take a look at the documentation for your distro to make sure that you're making the settings in the right place. And that's really what the network manager helps to solve. If you don't have the network manager, you can always consider installing it. The NMCLI, NMTUI, a lot of the tools we've talked about in other episodes can easily be installed on a server as long as it's okay in your security footprint.
Mm-hmm. Are there any other DNS gotchas that we should look out for?
Yeah, one of the biggest ones that I bump into is where I've set a DNS server, but resolution isn't quite working for some reason, and I find where somebody has overridden a value.
Oh,
now,
okay.
we usually would find that in our resolve configuration, like I was showing a moment ago, or in our network manager or somewhere like that. If you just run nmcli, it gives you an output of your configuration, so you might see where something is being overridden. But there's one more place you want to watch out for. Inside of /etc, you'll find a file in there called host. And that file allows you, or hosts with an S, sorry. That file allows you to override DNS, right? So when you make changes to this, it doesn't matter if you're using the resolve daemon, if you're using any of the other DNS resolution things like DNS mask or whatever, doesn't matter if you're using any of those, this file will override them. So if you're ever really scratching your head and you can't figure out why something is resolving a certain way, well, you can take a look at that file, /etc/hosts, and see if something's been overridden. Now, looking at it here, I see some multicast addresses and some loopbacks. That's not a big deal. So this isn't really going to impact anything. But if I saw an entry in here that was remapping www.google.com, right, that would be a problem. We don't normally do that, but some software applications will create false names to be able to reference your own system to help with resolution or loopback communications and other things. You might find them there. The other thing is, remember that we've got a number of different tools available for verifying that DNS is working. One of the older tools is NSLookup. It's a nice utility because you can run it really simple. I can just say NSLookup www.google.com and see if name resolution is working for me. But you can also just run NSLookup by itself, and it takes you into a command prompt where you can do all sorts of things. You can say, you know what, I want to do a lookup against server 8.8.4.4. Right? So now I tell it what server I'm going to be doing lookups against. And now I can rerun that lookup for google.com and maybe I get a different answer from this other server. So you can test things out from different servers. I could have actually done that from the command line as well. If you just add to the end, maybe I want to do a lookup against 1.1.1.1 like that. So NSLookup www.google.com 1.1.1.1. Now it's going to do the lookup against that other server. There's another command called dig. And dig will show you a little bit more information. When you do a lookup, it shows the question that you send to the server, and then it shows the answer that you get back, and it lays it out according to the original DNS bind format. So it's kind of formatted the way a DNS server would actually be handling it. It's a little more true to standard.
Right.
And sometimes you can get a little more information about this. And dig, if you pull up the documentation on dig, you'll see it has a ton of options that can show you all sorts of really cool things that help you to make sure that DNS is working properly on your system and you can kind of do testing with. So those two commands, dig and NSLookup, are usually installed by default on most distros, so make use of them.
Is it called dig because it digs deeper?
I don't actually know on that one.
That's what it kind of sounds like, yeah.
Yeah, sometimes they end up as being acronyms. In this case, it's just DNS
dig.
lookup utility, so I guess.
All right.
Yeah, NSLookup makes sense, right? Name server
Right.
lookup, but dig, I don't know.
All right. Well, this has been configuring name resolution. We looked at 3 common ways to configure. Anything else that you want to mention before we go?
These are the 3 common ways, but there are more. I think I briefly mentioned DNS mask at one point. Some servers do make use of that DNSMASQ, DNS mask. So that's why it's so important to check the documentation for your distro and make sure that you're editing in the right place. But the ones that I just showed you, those are the ones that you're going to encounter the most out there in the real world.
All right. Thank you so much, Sean, for guiding us through that. And thank you all out there for watching. Signing off for IT Pro TV, I've been your host, Aubrey Spurgeon.
And I'm Don Pizzette.
And we'll see you next time.
Thank you for watching IT Pro TV.
Lost network connectivity? Stick around and we'll show you how to troubleshoot your issue.
You're watching IT Pro TV.
Hello, Hello and welcome to another empowering episode here at IT Pro TV. This is your Linux Essential series, and in this episode, we're here to verify network connectivity. And with us is Don Pizzette. How's it going, Don?
It is going great, and this is going to be an easy episode for us because
Oh, yeah?
a lot of operating systems were not built as network operating systems from the ground up, but Linux was. And as a result, we have a ton of great troubleshooting utilities that are available from the command line that will help us in really any situation that deals with bad network connectivity. So in this episode, we're going to learn a little bit about how to test our, verifying our configuration, making sure that DNS lookups are working right, mapping out configurations, trying to see if a firewall is blocking us. We're going to get a chance to see a lot of that stuff, all using command line utilities inside of Linux.
So is there a quick way to check our network settings?
Yeah. We've seen in some of our episodes where there can be more than one place to configure things.
Right.
But nicely, the troubleshooting tools make it easy because we just have one tool that we run and we see the configuration. And so it doesn't really matter where that configuration is coming from. Because at the end of the day, when a device gets configured, that configuration is tied into the kernel, which is held in RAM, and so we're able to see that. A lot of the information is stored in the folder /sys/sys. You'll find all sorts of information in there, or in the /proc folder as well. So if we want to see things, we have our older commands like ifconfig that we really shouldn't be using anymore. In fact, on my system is not installed. But our newer tools like IP-ADDR are really great ways to just jump in and quickly view your configuration. If I run IP space ADDR, I can see my network adapters. I can see their IP addresses, and it's IPv4 and IPv6. I can see that. I can see whether or not they have a link and are up and on, or if they are unplugged and off, right? I would see all of that information right here, kind of a quick, easy way to view that and view that status. I can do IP route to view who my router is, if I have a default route in place or if I've overridden any routes. And if I just want to see if a link is up or down, I could do IP link, and I'll see the link status and whether they are up. See how this first one says loopback up. The ENS3, my Ethernet adapter, shows that it is up, and that tells me that it's on, working, and it has link lights. So I don't have to go and dig under my desk to see if I've got link lights on my computer. So as far as viewing the configuration quick and easy, those are great ways to do it. If you have other software, you can use it too. If you have the network manager installed, you can do nmcli, and it'll give you a dump of your configuration. You can see it there. But that's not necessarily what's actually running on your system. That's just what network manager thinks should be working. Tools like the IP command are showing you what's actually happening.
So with that said, what if our settings don't match our running configuration?
Yeah, so what that usually means is that we've edited the configuration, but the system hasn't read it yet. And that used to be a real problem back before systemd. Most modern distros use the system daemon or systemd to be able to manage configurations. And it reads configuration files on the fly. So when you make a change, it'll see it and it usually handles it automatically. Before systemd, we used what was called sysvinit or upstart, were kind of the two main ones out there. And they worked on script files. And they would usually only read those files when the services started up, and that was it. So you might have to restart the networking service in order to make those changes take effect. On an older system, we would do that with the service command. Now, I've got a newer system here, but let me show you the command anyway. I would say sudo service, and then I would say the name of the service. It was usually called network, and then I would just say restart, like that. And that would restart the network stack. And I'll get an error here on mine, but when you run it, that would restart the service. On a newer system, though, if you have systemd, and this is Ubuntu, Red Hat, CentOS, Debian, they all use systemd now, you would say sudo systemctl restart, and then the name of the service. And it's normally going to be networking.service. And when you do that, what it's going to do, it's going to shut down all of your network connections. It's going to reload the configuration files and then restart your network connections and bring them back online, right? So by doing that, now your configuration should match between what you see in nmcli and what you see in IP-ADDR. Whoops, IP-ADDR, there we go. Now they should match because it's loaded that configuration and it's fresh and clean. On a workstation, this is something I'll pretty commonly do. On a server, I don't like to do this because it does drop the network connection for a brief moment. But if you've got users in there, it's going to mess with them. They're not going to be happy about it. So you are taking the server offline for a moment.
So where should we start when we're trying to troubleshoot network connectivity?
All right. So if I've got I get a trouble ticket. Somebody says, "Hey, this server can't get on the internet," or I can't access this file server or whatever. The first thing I always do is establish a scope. Like, how big is this problem? Is it just affecting this one user, or is it affecting everybody, right? Aubrey, you're on a Mac.
Yes.
And I'm on an Ubuntu Linux machine. Let's say that I can't get to CNN's webpage, right? Well, that might be a problem in Linux, and I need to dig into my configuration and figure it out. But if you can't get to CNN either,
then there's a bigger problem.
yeah, you're not even running Linux, right?
Yeah.
You're running Mac OS. And so maybe it's a problem with our network. Maybe it's a problem with CNN, right? And they're down.
Yeah.
We need to establish where the problem is. And I used to, forever ago, just use the ping utility to do this stuff, because you could ping and go step by step on the way out, right? Let me show you how this would work. First off, I'm about to use 3 utilities: ping, traceroute, and tracepath. Each of these have IPv4 versions, which are the original ones, and IPv6 versions, which are the new ones. If I say ping on an IPv6 network, I would say ping 6. Or if I was doing a tracepath on an IPv6 network, I would do tracepath 6, right? So just add a 6 to the end of any command for IPv6. But I'm going to do IPv4 here. So I would do a ping, and the first thing I would do is I would ping my loopback, right? The loopback is a virtual address, 127.0.0.1, that's mapped to the software that drives our network adapter. If I can ping that, that tells me my networking software is functioning right, okay? I might have physical problems, but the logical side is at least working right, okay? Then I would ping whatever address I had on my system. Now, my address is 192.168.50.129, and so that would be the next thing I would try and ping, is to ping that one. And when I do that, paste. Whoop, that didn't work. So let me just type it then, since I can't seem to copy and paste. There we go. If I can ping that, that tells me that my network interface is working, because now I'm actually having to talk to the driver, because that's where that IP is assigned. I can talk to the physical network adapter. Then I would ping my default gateway. If I do an IP route, I see my router is 192.168.50.2. So that's defined right here in my default route. So can I ping that? So I'll try and ping 192.168.50.2. And if I can ping that, now I know I can get from my laptop to the router. So that's pretty much it from my building. Once I get beyond the router, now it's my internet service provider. And there can be any number of routers in between you and your destination that could be causing the problem. And so you can use a utility like traceroute to figure out what those systems are. So I'm going to run traceroute, and let's say it is cnn.com. So I'll do traceroute www.cnn.com. Then it's going to go and figure out the path in between. Now, traceroute's an old command, and I can see I don't have it installed, so it's not working for me.
Right.
What I would normally do is do traceroute. It would give me a list of the routers, and then I can go and ping each one individually, right? Well, that's a lot of work to go through. And so we have a newer utility, which is the tracepath utility. And what tracepath does is it combines ping and traceroute and does them together. And so if I do tracepath www.cnn.com, it's going to go through and calculate, and it's figuring out what's in between me and the destination, and then it's doing a ping and giving me the average latency over here. All right. Now, as it starts to run, what we'll normally see is a list of routers here, and notice how mine dropped off right at that gateway. Okay. Well, that's here in the building. In the IT Pro TV, we hit our gateway, and then we jump to the ISP, and I'm getting no replies down the line. That's usually indicative of one of two things. Either one, my internet connection is down, right? So I've got a problem with my ISP. Or two, a firewall has blocked path ping from doing its resolution, or a tracepath in this case. So it's more likely going to be a problem here with the firewall blocking it. So if that happens, you might not be able to use tracepath to be able to do that. Traceroute might work, but your firewall might be blocking that too. I might have to go and update the firewall to reflect that and allow that communication to go through. Let me do traceroute is part of, I can install it directly. So I'm going to do a quick install of that one. I'll do sudo apt install traceroute, and we'll get that installed real quick. It's a very small utility, so it'll install pretty quickly. Oh, shoot.
You say that, but...
I know, I say that, and then it's pulling a firmware update at the same time, apparently. So so we're going to get traceroute, and then we'll run and see if that gets through. Otherwise, I have to go and edit the firewall configuration to allow that communication to go through. But what these utilities are designed to do is to show you what's in between you and your destination and see where you have a drop-off and a failure. With the output that I was getting, it looks like that failure is beyond my gateway. So I probably need to call my internet service provider Or if I manage the firewall, I need to take a look at the firewall. But either way, I now know the problem is not here on my laptop. The problem is beyond the laptop. If I didn't even get to the gateway, then the problem would be here on my laptop, and I need to go and look at my configuration. Maybe I'm pointed to the wrong router. Maybe I've got the wrong subnet mask. These are all little things that could be going wrong that these tools help us to find. All right. Oh, traceroute finished. Let's try that one real quick. I'm going to do a traceroute to cnn.com, and we'll see if that one gets any further. It looks like it's going to trail off too. Yep. It sure did. All right, so that one died off too. So I know, though, that I did get to my router, so the problem is somewhere beyond my router that is stopping that one.
Okay. What if name lookup fails? Can we test that as well?
Yeah. Name lookup, we've got a couple utilities that are pretty much installed everywhere by default. One of them is NSLookup, which I know we saw in another episode. You can do NSLookup followed by a name like www.cnn.com, and it's going to show you what server you use to do the lookup, and it's going to show you the results that you got back. If you don't get a result, maybe you're using the wrong DNS server. You could try different DNS servers from the line. You could say NSLookup followed by a domain name followed by a server. So maybe I'll use 1.1.1.1, and now it's going to run the lookup against that server instead and get us a result back, and so we can test that out. Sometimes it's nice to be able to test across DNS servers around the world. This will just show us whether or not DNS is even working. We also have the dig utility, which does basically the same thing, but it's a little bit more verbose, gives you a bit more information. So when I do a lookup for cnn.com, I get the answer back here, and it shows this in a standard DNS style format. This conforms to the bind configuration format. So it shows me a little bit more information there on what that lookup was like.
Is there anything we can do if we think a firewall is blocking us?
Yeah, so in my case, there is a firewall blocking us, right? So depending on the protocol, you might be able to try and connect on a single port. Ping is a great way to test something. Can I ping a server?
Right.
But maybe ping is blocked, and you're not allowed to ping the server. But it's a web server, so you are allowed to connect on port 443 or port 80 or whatever, right? So it's hard to rely on one tool to do this. This is why we have so many different tools to pick from. So let me show you an example of that. Let's say itpro.tv, right?
Yeah.
I'm trying to test my connectivity. Can I get to that site? And if I just do a ping to itpro.tv, or actually I'll do www.itpro.tv, all right, I'm going to ping to it, and yeah, I can actually ping that, right? It's on a CloudFront system, so I'm able to ping that, and I'm getting responses back from it. But pings might be blocked, and then I would only be allowed to connect via web ports. Well, how do I know if that's working? I could fire up a web browser and try and browse to it that way. That should work, right? But if I think there's a firewall blocking me, I'm not going to see any output. It's just going to time out, right? Connection timed out. So I could try it by hand. There's a neat utility via the command line called netcat, or NC. It might be installed by default, but a lot of times it isn't. You need to install it, but every distro has it in their repositories. I can see mine's already got it. I didn't install it, so apparently it's in by default on Ubuntu. But with netcat, you can connect to any service. FTP, Telnet, SSH, HTTP, you can connect to anything with netcat. But you've got to know the commands to talk to whatever it is that you're connecting to. Some things are really obvious and easy. Some things are really hard. Like, let's say I want to connect to a web server, and I'm just going to do regular port 80, right? So not a secure communication. So I can say nc www.itpro.tv space 80. I'm going to connect to that server on port 80. All right. Now, if a firewall was blocking me, I'm not even going to be able to connect. So I'll probably get an error and it drops out. But if it sits here like this, I've opened up a session and I'm probably talking to the server. Probably. How do I know? Well, if you know HTTP, you can do a get command, and I'm going to ask for the root web page, which is just a /, and then I need to tell it that I'm speaking HTTP/1.0 as my language. All right. And then I need to tell it the host I'm requesting. Whoops, I timed out. Shoot. Oh. So let's try this again. I rabbled on too long. So I'm going to request that page. I'm just typing the exact same thing again. And then I need to tell it the host that I'm requesting, because there might be more than one host. So I'm going to tell it that I want www.itpro.tv. And then it's going to request the page. And I should get an answer back. In fact, I did. I got an answer back saying HTTP 301 moved permanently. All right, well, what does that mean? Well, if I look, I can see where I connected on port 80. That's not secure. But down here, I can see that it moved permanently, and it's trying to send me to HTTPS www. So if I'm trying to connect on port 80 and it's failing, it's probably because all there is a redirect that's trying to send me to 443. So maybe I've allowed outbound port 80 on my firewall, but not outbound port 443 on the firewall. And so now I'm not able to connect to secure servers. It's a silly thing to do, but I've seen it happen, right? And Netcat gives me that information. I'm able to see this. A web browser wouldn't show me a redirect. The web browser would just do the redirect, right? I wouldn't even know that it happened. Here, I can actually see it. So tools like Netcat give us great visibility into what's going on in our communications, and that really helps us with troubleshooting it. One more thing we can do, let me break out of that for a moment. I'm going to create another tab, and we can actually view these sessions as they're being created. So when I reached out to that server and I did that get, oh shoot, I made a typo. Well, that'll work for me. So I just did a bad request, so it's giving me an error. You can use the SS command, and you can do like where you pipe it into grep and look for port 80. And you can see whether or not you're even establishing a connection at all, right? See how mine says close-wait? That's telling me that I had a connection, and right now it's waiting to close. If I don't send any more stuff, it's going to close on me, right? It'll idle out and close. If I see this saying initializing and just sitting there, that means that I never actually made it to the server. I'm trying to get to the server. Hey, please talk to me on port 80. But the server's never replying back. I'm initializing, right? It's part of an initial handshake. So you can see the status of that connection. And so what I ran there was SS-AN, and then I piped that into grep, and I looked for :80. I was looking for that port number. If I was looking for like a SSH connection, I would look for :22. That's the SSH port number. So looking for specific things like that, you can see those sessions that you may or may not have built up.
All right, this has been Verifying Network Connectivity. Don gave us some tips for troubleshooting. Do you want to remind us of those tips?
Sure, yep. And first off, establish the scope. The problem might not be the machine you're on. It could be your entire network, or it could be the destination. So always try and get a good handle on that. Remember that you've got the ping, traceroute, and tracepath utilities, which are phenomenal at establishing where your network gets cut off in between you and a destination. So those are great tools. Remember all the tools for just looking at the configuration. IP ADDR, IP route, the older ifconfig commands, NMCLI. Those commands will give you a quick output so you know exactly what your configuration currently is. And then if you really want to get advanced and do some digging, Netcat, the NC command, it will let you talk to any protocol as long as you know the language to speak with it, and you can do some additional troubleshooting there. Tons of tools, and this is just the tip of the iceberg. There are tons more out there, but these are the most common ones.
All right, there you have it. Thank you so much, Don, for guiding us through that, and thank you all out there for watching. Signing off for IT Pro TV, I've been your host, Aubrey Spurgeon.
And I'm Don Pizzette.
And we'll see you next time.
Thank you for watching IT Pro TV.